Transform your home into a self-sufficient, energy-efficient home. Become energy independent, reduce your bills. Solar panels can provide a significant source of electricity for the home. At times, when your electric load is low and the sun is shining, you may even be able to get paid for sending electricity back to the grid.
I decided to do solar because I think we all should be trying to do things to make a better environment for the future. The cost of power going up in the future, it's for residents, it's an economically viable proposition. And actually, if you're a commercial business, there are greater ways to either get credits and or reduce the cost for your system. So solar is something that obviously is technology. The technology is here, and I think with our incentives, the finances are here.
Photovoltaic systems are modular. You can start with a basic system and add on as needed.
The cost of utilities continue to rise. I think you'll see more and more people, particularly in the sunshine states like Arizona and Florida, California, and Texas, go to solar.
First, we will look at a solar array built on the ground. This is also called a solar photovoltaic or PV system. The frame to hold the solar panels is built with pipes.
The solar electric system we're installing today is 4.5 kilowatts. The array is divided into 4 subarrays. There's 6 modules in each subarray. They're rated at 24 volts nominal. They actually produce somewhere between 36 and 50 volts. And they're wired in series, so our voltage coming into the control center varies between 300 and 400 volts. So each array wiring comes into a combiner box where the positive circuit goes through a fused disconnect. So if we have it's overload protection. From there, the circuit is combined into one set of wires that carries the total amperage of the whole array. And that goes into a DC disconnect, which is just simply a switch to be able to shut off the array in the need of maintenance. So from the DC disconnect, the combined voltage comes into the inverter, where it's transformed into 240 volts AC standard house current. And from that point, it goes inside to the house through an AC disconnect, which is a means to shut off the system for the power company in the event of a grid failure, so that they can isolate out the power and safely work on the grid. And then it goes into the main panel distribution box in the house through a breaker, in this case a 40 amp breaker, that backfeeds power into the house circuit, at which point the homeowner either consumes the power directly during the day if the system's making electricity, or if there's not enough of a load in the house to consume the power, it backfeeds into the grid and essentially makes your meter turn backward.
This system, when completed, is rated at 4.5 kilowatts. That means that it is capable of putting out 4.5 kilowatts for every hour in which it gets enough sunlight. So if it gets full sun for 5 hours in a day, it would generate 22.5 kilowatts, which is the same as 22,500 watts. There are 1,000 watts in a kilowatt. Of course, the number of kilowatts generated will vary according to the amount of sun. The frame has been set up to hold the panels at an angle that will capture the most solar energy for the maximum length of time throughout the year.
These are the individual power leads coming out of each module, as where we're putting several modules in a series circuit. So what we're doing is taking a positive and a negative and joining them from each module, and we put them in a string, and then at the end we'll take the positive and negative from the end modules, and then we'll have a large series circuit to where we'll end up with 300 to 400 volts DC, and that allows us to have a longer run with no voltage drop, or very little voltage drop. This is the combiner box, and what we're going to do here is combine each series string of panels into one circuit breaker, and then those will all be tied together and be looped in as your DC positive to your inverter. In order to meet code, we'll have to bond to each one of these rails that hold the panels onto the array. So they're all at the same voltage potential.
Wires going in and out of the combiner box, the inverter, and the DC disconnect box are run through conduit. The conduit goes underground to the outside of the home. This system was built on the ground, but solar PV systems can also be built on either flat or pitched roofs. Now we'll look at a solar array built on a roof. A pipe frame is not needed. The solar modules are connected to rails that are connected to posts that are attached to roof trusses or rafters. The wiring is the same, but fitting the wires under the panels is a little more difficult on the roof.
Then the two plug together to make a waterproof seal.
This is tying in. Each set of conductors will carry the power from each line of each string of modules and deliver that DC power down to the DC disconnect, which will in turn feed the inverter.
Just like the system built on the ground, wires go to an inverter.
The wiring coming down from the array on the roof turns into AC power and goes out there. There's a switch like this out there that the power company will use to shut you off if there's a problem out on their lines. Right. And there's a circuit breaker out there to protect this whole apparatus from a short circuit.
The system is simple to operate, and Solar Direct technicians will be glad to provide information and answer questions.
You only need to know that that green light is on solid. Because this inverter, if the sun's out, this inverter is on, whether the grid is on or not. This inverter's got power. You'll see these lights on.
It won't do it.
But if the solar's on and this failure light is on, it'll tell you there's a grid failure. But this red light down here will be on.
And then when they throw the power back on, it just automatically...
It automatically finds itself and comes back on. You don't have to do anything. Sometimes in the morning, if you see this thing, this will be flashing and it'll say waiting. That means
waiting for the sun to come out full swing.
It's waiting to come up to full power because the sun, enough voltage to start up. What happens is when this comes on first thing in the morning, it'll pick up the grid and it'll take maybe 10 minutes to tie in.
But what's interesting to observe or watch, there's a panel here, and it has 3 readings that you can that continuous display in digital form. The one reading, it shows what your power is at the moment, so it gives you a moment by moment identification of how much power your solar system is producing. So it gives you a pretty good idea how your system is working. The energy company will have a separate meter, electric meter, that will be measuring how much power I produce that goes into their system when I do not need the solar power that I'm producing.
So, but if we produce during the day more than we use during the day, do we get credit for that system?
Yes. Oh yeah, you'll actually see the numbers counting down instead of up.